Okay, here I am. This is our lesson on section 6.2, the equation of a line in standard form, ax plus by plus c equals 0. What I want you to do with this video, first of all, is learn everything that you can without me in the classroom. So I am here now. You can pause the video at any point and write stuff down on your paper. You can rewind the video and re-listen to it. So it's a great instructional strategy for you to be able to watch this and learn from it, okay? So here's what we're going to do. You've already been handed out the investigation. Hopefully you worked with a partner and you got everything figured out. Mr. Garland was able to help you with it, and Ms. Curry as well. And now you're watching the video. We're going to do a couple of examples together along with Ms. Curry. Mr. Garland can help you as well, but here we go. We're on page 312, and we're going to look at a couple of questions. My strategy for expressing an equation in the form y equals mx plus b. Question 1b, 2x plus 3y plus 6 equals 0. First of all, you can see that this is in standard form, ax plus by plus c equals 0. So it totally looks like ax plus by plus c equals 0. What we want to do is try and write this equation in the form y equals mx plus b. In order to change forms, of course, you need to isolate y in this equation. If you're going to isolate y in this equation, then you must look at everything that y is attached to first. I like to draw a box around the term that I'm trying to isolate. I want to isolate y, but notice how I've included the positive 3 in front of the y as well. So that's the coefficient of y. It's easy to visualize what needs to go to the right-hand side, and that's obviously the 2x and this plus 6. We're going to move to the right-hand side. Two ways to go about it. And one way that Ms. Arva showed you is to just simply draw an arrow. We're moving the 2x to the other side. When we move something to the other side, the operation changes, or the sign changes. Right now there's an invisible positive sign in front of that 2x. So when we move it to the right-hand side, it becomes exactly, negative. When we bring this positive 6 to the right-hand side, it becomes perfect, negative. Okay? So that's exactly what we're going to do first. We're going to move things across the equal sign. The other thing that we can do, the other strategy, is to just perform the opposite operation. And that is also something Ms. Arva talked about. So right now, in order to get the 2x removed, you subtract 2x on both sides. Okay? If we subtract 2x on both sides of the equation, notice on the right-hand side we have 0 take away 2x, which is going to be negative 2x. If we take away 2x on the left-hand side, these two quantities are going to cross out. So whatever strategy you use, it's important to keep the equal sign lined up so that you're balancing left and right side so that you're not confused. If I subtract 2x here, then I have a negative 2x on the right-hand side. If I subtract 6 on both sides, you can see that on the left-hand side, 6 take away 6 is 0. On the right-hand side, I have exactly that, negative 2x minus 6. What is remaining on the left-hand side? Well, on the left-hand side is the box, the blue box. This positive 3y. And the positive 3y is, I don't need a positive sign because that's a known quantity. There's a positive, invisible positive sign there. Now I'm going to put a box around the actual variable that I want to isolate. That's what I want to isolate now, so it's obvious that I have to get rid of the 3. The 3 is a coefficient of the variable y, and coefficients of variables are multiplied together. This is 3 multiplied by y. So in order to get rid of the 3, I need to divide both sides by 3. Dividing on the left-hand side, 3 divided by 3 is 1. So you're left with 1y, or just y. dividing on the right-hand side, well, I have two terms and I'm dividing by this 3. So what I can do is I can split the two terms into into two fractions. So what I'm going to have is negative 2x over 3, and I'm going to have a minus 6 over 3. So notice how I've just split up the fraction into two terms. And the reason why that works is it's the opposite of getting a common denominator in the first place. If I could just do a little aside here without causing too much confusion. If I just asked you to add two fractions together, so for instance, if I asked you to add 3 over 2 plus 1 over 4, if I asked you to add these two fractions together, this has nothing to do with this problem, this is just something that is going to help you with the split here. What I would have to do is multiply this fraction by 2 over 2, because I need to have a common denominator in order to add fractions. 3 times 2 is 6, 2 times 2 is 4. This fraction doesn't change. What happens in the next step if I'm adding two fractions together and they have a common denominator already? Well, we write the denominator once and we add the numerators together. So our answer, of course, would be 7/4. That's what our answer would be. But look in this step. What happened to get from, if I work backwards, what happened was I split the two terms in the numerator into two separate fractions. I split the 4 in both fractions. We all know how to add fractions, but quite often we never look backwards, and that's exactly what we're doing with this 3. The 3 is like our common denominator, so we've split it, and we're working backwards from this step to this step. And that's exactly why you can split the two terms in the numerator into two separate fractions with denominator 3. All right? So my aside is gone, and I'm looking back on my problem. Now, if I have a negative 2x in the numerator and a 3 in the denominator, we've talked about how this is the same thing, negative 2/3 multiplied by x. And I can always simplify this. 6 divided by 3 is 2. And now you can see how we have our equation y equals mx plus b. Right? Y equals mx plus b is exactly y equals negative 2/3 x minus 2. We've been successful at changing this standard form equation into y equals mx plus b form.